Welcome to the lectures on problem solving and programming in C. This is lecture 26. The title of the lecture is searching. So in many occasions, searching we do every day because we want to search for whether something is there in at some place or not. And computers also searching and sorting. Sorting is basically keeping the elements in a particular order, in either increasing or decreasing order. These are the very fundamental problems which are very much required in any applications or computer science applications. Okay. So what do you mean by searching? We're given on a list of elements. We want to see whether a particular element is present in the list or not. Okay. Right. So let us see how to develop procedures for that. Right. What is searching? Given a list of elements, check whether a particular element is present in the list or not. There are two kinds of lists, sequential search, another one is binary search. Binary search requires elements to be in sorted order. So if the elements are already in sorted order means if they are in increasing order or decreasing order. So we can use the fact that they are ordered, and then we can intelligently search and reduce the time computational time it takes to search an element. Okay. So first, let us focus on the sequential search. Okay. What you have is you have a list of elements. You have a list of elements L0 to N minus 1. And then you have a key K. Okay. What you need to do, whether K is part of the list. If K belongs to L, then we should say yes, element is present. If K does not belongs to L, then we should say no, the element is not present in the list. Okay. These kind of situations where very much come when you are implementing a lot of many applications, computer applications. Okay. Now let us write a first thing algorithm. So let us first straight away write a procedure. Procedure search. Search. So what are the arguments? Argument will be n number of elements, L0 to n minus 1, then K. These are the three arguments. What is the input? Input will be n, and then L list L0 to n minus 1 and element K. Okay. What is output? Returns 1 if K belongs to L, 0 otherwise. Then begin. How do you check whether what I can do is I can take out one element by one. Suppose I have a basket of balls. Okay, I want to check whether and it is closed. Okay, I cannot see all the balls at one go. So I want to check whether the ball with color pink is there in the basket or not. What I can do is I will pick one ball and look at its color. And then if it is not pink, I will put it aside and keep on searching for all the balls. And then once the balls are over and I could not find the pink color ball, then there is no pink color ball in the basket. Otherwise, whenever I see a pink color ball, I can immediately conclude that the pink color ball is present in the basket. Okay. The similar technique we will use. What we will do is we need to access balls one by one, right? So we need to access elements one by one. So that is why you have to use the repetition. So we have L of I, right? If L of I is equal to K. What does it mean? It means that we got a pink ball. If you are looking for a pink ball and you taken out a ball and its color is pink, then we can immediately say that return 1. And if. Okay, and for. You have processed all the elements and you didn't find a pink color ball, then you say that there is no pink color ball. So if you processed all the elements and none of the elements match with K, then you can, after the processing the last element, we can say that there is no element in the return 0. And end. Okay, this is the search function. Okay, search function which takes number of elements and the list elements and the K. Okay, so let us try to implement this. CP test match to search, sequential search, sequential search. So we need to read the number of elements. We need to read the elements. Okay. Then after that, we need to read the k value. We need to read k, int k, printf. Sorry. So this should be after here. Once you read the element, we need to read the element we want to search. Printf. Enter a number you want to search. Int k, input k, right? So that's why I'm asking this. Scanf %d ampersand k. Okay. Then we will call this function int search status. Search check search plus status. Search status. Found equal to search of in n comma l comma k. If you pass this, suppose if found equal to 1, what does it mean? Then printf element is found. Otherwise, else element is not found. Okay, but we need to write this search function, search procedure. So return type is int search. So int n comma int l comma int k. This is the prototype. For int I equal to 0, 0, I less than n, I plus plus. This is the for loop. I'm just translating this. I'm translating this. Okay. If L of I is equal to k, then return 1. After for loop, otherwise return 0. I just translated this procedure to a C function. And we need to declare this prototype at the top of the main function. Okay. So these arguments are not mandatory. We can remove. We can even keep them, no problem. ECC list sequential search. Compile. Okay. Let's say 10 elements. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So whether you want what you want to say, let's say I want to search 60. So 60 element is found. Similarly, let us try again. 10 elements, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Element you want search is, let's say 55. Element is not found. So it will search whether the element is present or not. Okay. So especially if the elements are sorted. So for example, if the elements are 2, 4, 6, 8, 20, 30, 50, 70, 80. So let's say elements are already sorted in ascending order, okay? Ascending order, increasing order. So suppose if I want to search for 10, okay, 10. So what I can do is I can search in the middle element. Middle element. So based on whether the middle element is bigger than, so suppose 10 is smaller than 20. So there is no, all the elements on the right side will be bigger than the 20. So I no need to search, because 10 is going to be, I know that 10 is going to be left side of 20. It cannot be on the right side of 20. So I can ignore searching on the left right side. Similarly, if I want to search for 50, I know that it cannot be on the left side, so I can ignore the left half. I can search only on the right half. So that this kind of this saves a lot of time, because the time complexity is basically every time you are discarding half of the list. The sequential for search takes order n time, n computations and worst case. Okay, whereas sequential, whereas binary search take order log n time, log n computation and worst case. Okay, so this is very efficient. Only thing is the list has to be in sorted order. Okay? So this we will discuss in further on how to develop. So let us develop a search function to do a binary search. Okay, same search function we will use. Yes, procedure. This is the procedure. So let us say this is removed, and let us remove this. I'm right away writing a procedure. This procedure expects a expects an list n where L is sorted. Is sorted in ascending order. Ascending order is basically increasing order, increasing or non-decreasing ascending order. Okay, when you are calling this function, you have to make sure that L is already sorted in sorted order. So what we can do? So what I need to compare the middle element, right? Middle element equal to so I can say n by 2, n by 2. So let's say what is the left index is 0, so right index is n minus 1, middle index is L plus R by 2. Okay, L plus R by 2. So we can check whether as long as L, so it means the left, this is an array element, this is pointing to left, this is pointing to right. Okay, and every time we are going to discard half of the list, so we'll adjust left index or right index accordingly. So as long as L less than or equal to R, it means that there are elements, while L less than or equal to R do. Okay, M equal to, so this is not needed here, this is not needed, it's not needed here. M equal to L plus R by 2 if L of M is equal to K, then return 1. We find the element, we can return 1, right? Else if L of M is greater than K, then what does it mean? The middle element is bigger than K. It means that K will be on the left side, right? So we need to adjust this right pointer to here. So R equal to M minus 1, R equal to M minus 1. Else we need to, suppose if we need to search on the right side, L has to be come to here, M plus 1. It's L equal to M plus 1. And if, and while, then end of the program. End of the program. Okay. So this is a function binary. This is a sequential. It's not a sequential search. It's a binary search. binary search. So it takes a list, L in ascending order and a K. Returns 1 if K belongs to L, otherwise 0 otherwise. Okay. So L equal to 0, R equal to n minus 1. As long as L less than equal, see basically L is moving this side, R is moving this side. At some point in time, they will cross each other. It means when they cross each other, it means that we have searched the entire elements. Okay. So L less than equal to R, we will compute the middle element in this sublist. So middle element basically L plus R by 2 means you will get here. Okay. So we cannot say n by 2 because these L and R values are changing. If you do n by 2 or R by 2, so this will be out of our range. It can be out of our range. So the best expression will be L plus R by 2. If L of m equal to 2, then it means that we have found the element. Otherwise, we will adjust either the left index or the right index to discard the half of the list, unwanted list. So this function we will implement by when we are doing this sorting algorithm in the subsequent classes. Okay. Thank you. I will stop here.